3, 2, 1. Hello, on October 26th, my cat made a giant mess on the floor. But actually quite proud of him. It shows his tenacity at dealing with. I was talking about those. I think he's destroying the bag. Alright, anyway, let's see what we have today. Number of laser beams in a bank. I remember this one. Anti-theft security device are activated inside a bank. You're given zero-indexed binary string array bank representing the floor plan of the bank. Yes. Which is a M by N 2D matrix. Bank I represents the ith row consisting of 0 and 1. 0 means the cell is empty. 1 means the cell has a security device. There is one laser beam between any two security devices if both conditions are met. The two devices are located on two different rows. For each row in between, there are no security devices in the ith row. No security devices on the ith. For each row in between R1 and R2, there are no security, okay? Laser beams are independent. One beam does not interfere with nor join with another. Return the total number of laser beams in the bank. Total number of laser beams in the bank. I don't remember this problem. The two devices are located on two different rows. There's one laser beam between any two security devices if both conditions are met. The two devices are located on two different, so it has to be on two different rows, and there should be no devices in the rows in between. Only so basically if we have additional devices on this row, then there will be then these will not work. So in this case I have 3, 2, that's 6, plus 2, that's 8, right? Note that there is no beam between any device from the zeros, I think this is zeros, and 0, 1, 2, 3, and third row, because 2 and then the 2 had devices, which breaks the second condition. There's null because we don't have anything else. Okay, so essentially we start from, so we're going to give a matrix, right? Alright, so we have a first row, right? And if I have a second row that it contains, then they can have beans. If it's not, so we just look for the next one that has. Okay, then we forget about it. Then we just go for the next one that has it. Yeah, that's it. Seven. Start from the first row that has security. Find the next one that has security. Compute the number of beans. Then forget about the first one and make the second one the first one and repeat. Alright, I think that's OMN. Alright, so I need to find the first. I need to find the. So I can say pre and current. And I need an int. Okay, so while current smaller bank dot size int count is 0. I need to count. Zero. Okay, count is 0, and then we say 4. It's a char, right? Oh, it's a string. Const auto b of bank current and count equal to b equal to 1. Okay, and then in fact, I think what I need this pre is this should be the count, pre-count, and this is I. Okay, this should be the pre-count, current count, and then this is I. Then we can just do for I, right? For alright, and then I plus plus. And then we don't need this. This is just going to be current count. And then we say current count plus equal to this. Okay, and then we're going to multiply the previous count. Alright, and then if current count larger than 0, we can first say rest plus equal to current count multiplies by pre-count. If it's larger equal to 0, then pre-count equal to current count. All right. Huh. between an integer and a const char. Isn't that straight? I don't understand. Oh, my bad. I completely botched this. So sorry. This is so wrong. Alright, so if it's 0, then we don't change, but if it's something that we do, and then next time we change. Okay, yeah, this looks okay. Yeah, looks okay. Let's try it. It's very simple. 3 milliseconds. 84, 39. Third time we did this. 2022, 2024, and 2025. Wow, it's almost January the 1st. Interesting. Very interesting. Yeah, count. I like to see the evolution, right? The evolution of my solve process. Okay, yeah, this one's done. So back to this one. Congratulations, annual badge 2025. Solving problems 300 plus days. Huh. 300 days. It's been 300 days. Yeah. It's 1942. We have 38. No, we have 58 days to go before we hit 2000. Anyway, so this one doesn't work. Okay, I have a new kind of idea. All right, so still, we have, blah, 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 blah. So I'm ditching this idea because this one times out. So what I'm thinking right now is I'll find the maximum range to begin with, which means I'll find the merging number, right? The merging number. So the idea is as the merging number, if it doesn't hit, like if the merging number is in between two already existing number, then the result will not change. The result will change if we hit the merging number hit something, or the right side hit something. So basically, And actually P should be A0 plus K, right? And then the n number, we have the n number, whatever the n number is, okay? So we have the right bound. So the left bound is A0. The right bound is going to be A0 plus 2K, right? And then the margin, this is the starting position. And we'll also go through everything, find everybody's frequency, right? And then we check for P, right? We check for P and then we do the same stuff and then we can get how many we can have, right? How many we can have. So we get a result. And after that, right? After that, we have, so the P can be like, the P can be somewhere here. And then the right bound can be somewhere here. The left bound is here, right? Left bound is here. So we're gonna move forward. So as we move forward, it depends, right? So as we move forward, this one will lose, right? We'll lose this, so we need to record, right? So we lose this. So basically we have 3, and then we have 3. So we also need, so we have I, okay? It's the left bound thing. It's not left bound value, but it's the left in indices, right? Left indices. We have J is right indices. And we need another one. I cannot call it K. Let's call it something else. We call it M. Okay, it's in the middle. So it's the middle index. So we have 3 things. So after the first round, we have the delta, right? Delta I is, nums I plus 1 minus left bound. Delta M is num. It depends on which one you're talking about. Is it matching one or is it the next one? Let's all go to on the left hand, either matching or it's the left side. So this one can be unified. So it should be m plus 1 minus p. And then delta j, right, the right one, is num j plus 1 minus right bound, right? So we will find the smallest amount of 3. Okay, we find the smallest amount of 3. And that's the amount we will move forward, right? And once we move forward, we will check, because with the smallest, so as we move forward, only one of them will hit the actual value. And while we're doing this, it will not, within the process, it will not get any bigger, the total thing. It will remain the same, right? Or it actually is going to get smaller. So we just let it move forward, and then we'll hit something, right? It will hit something. And we don't care which one it hits, but something will get hit. And we will check which one it gets hit, right? So we have 3 scenarios. Actually, it doesn't really matter which one get hit. The only thing that matters is if, it doesn't matter which one get hit because, well, I mean, we can simplify the logic, right? If the left bound get hit first, then it actually doesn't mean anything, right? The left bound get hits first, so the right bound doesn't get hit, and the middle doesn't, the convergent doesn't get hit. So what we have is just the original minus 1. So we actually don't really care about that, right? Do we? We don't care about that. and then the left bound basically we reset, and then we have a new value. Yeah, but it doesn't really matter, does it? Yeah, and the left bound got hit, we reset. It doesn't really matter. And then we check again, right? We check again. Now all three get changed, so we check again. Because when we move forward, we always reduce, right? We always reduce. But I kind of want to avoid doing too much binary search. So yeah, if the left bound hits first, we basically update I, right? We update I, update all the deltas, and then we just continue because we know the total, the size is not gonna get bigger. So now if the middle gets hit, so when the middle gets hit, yeah, every time we run this, we'll remove a value. We have to remove a value, right? We have to remove a value. Actually, we should remove the value before we do it. It's okay. We do it. We remove the value, and then if the middle get hit, right? If the middle get hit, then it's the same duration, but we might be able to get a better deal, because if that is the merging number, then we can save on the operation, right? So we do that. That could be a bigger value than before, right? And then we update. And if the right gets hit first, then we have a bigger, right? So basically we just sliding forward, so each time we hit one, so in total we'll do ON. So that is the idea. I'm actually not sure which one it is. Hold on, let me check which one it should be. It's the 22nd. 27, 6, 5, 4, 3, 2, 3, 3, 4, 7, right? 3, 3, 4, 7. Okay, that's solution 1. And essentially we have solution 2. Let's try solution 2. Yeah, I know I said I'm gonna give it up, but I don't want to give it up. Oh, whoops, doozy, that's not what I want. So I simply don't want to give up. And I have a new idea. Let's try it. Basically, what we'll do is we will start with left bound equal to non-zero, p equal to num0 plus k, and right bound equal to num0 plus 2k. All right. With this, we can compute the index, right, for the right. Call it j, and the index for the largest number that is not bigger than p. Call it largest, not number, largest index. Call it m. Right? Then we move the entire window to the right. The amount to move is the minimum of the 3 deltas. Di, equal to nums I plus 1, and we call the index for the left I. Okay, so this minus left bound dm is nums m plus 1 minus p, and dj is equal to nums j plus 1 minus right bound. After we move, we can figure out, right, the new this p and right bound, as well as the new I m j. From that, we can find out the length of the subarray, right? The length of the subarray. Yeah, we keep doing this and keep tracking and keeping track of the max length. We shall have the result. All right, so when we hit the end, okay, no, j cannot move forward, but it's fine, right? The right bound is just going to be there, and the left bound is just going to keep shrinking, which I think is fine. And in the end is just, go to the end. I go to the end. So we still do all of this. We don't do any of this. Okay. So we sort, we have a counter, and we have a left bound as num 0, right? P is num 0 plus k, and right bound is nums 0 plus 2k, 2 times k, right? And then int j shall equal to upper bound, nums dot begin, nums dot end, right bound, right? So this one minus 1. So we shall say std distance nums dot begin to this minus 1, right? Int m distance nums dot begin, upper bound again, dot begin, p minus 1. Okay, so now I get everything. Oh, I do still have to do the binary search. Oh, actually, no, you don't have to. Because everything will move forward in the same amount. Yeah, I don't think you need to do binary search again. So what we do is just for I equal to, until we hit the end, right? When we hit the end, when we move forward, is essentially only 2. Let's move forward. So I0, I smaller than nums dot size, I plus plus. Okay, so that's the whole journey. We have to have a rest equal to, let's call it rest equal to 1. Upper bound, what the hell happened? I forgot nums dot end. Okay, so what we do is we need to add them in. So for int I equal to 0, I smaller equal to j, I plus plus, we have to put counter nums I plus plus. Okay. Okay, so now is this. So if I is larger than 0, then counter nums I minus 1 minus minus. Okay, so this is to update. Then what happens is we'll check the size, right? The size shall be num operation plus max frequency. That's the total we can get, right? So what we shall do is, like, we have all of them ready, so shall be the minimum of num operation plus counter dot at. Actually, it's fine. Counter p, not yes, counter p. P is the convergence, so this is the maximum that we can get, and then j minus I plus 1. This is the total length, so we pick the smaller of the two, and then we say res equal to maximum res and this. Okay, done. Now we're gonna move forward. So di shall equal to so this is we're done, right? So everything is updated, and then we need to know what's the next one minus the current bound, right? Current bound. Now it's the next one to the current bound. So if the next one is going out, which means if I is already at the end, what do? We don't do anything, right? We don't do anything. So essentially, I plus 1 is smaller than nums dot size. Yeah, let's just do nums dot size. Say n is nums dot size. Okay, so all the nums dot size is just gonna be n. Right, so if it's smaller than n, then di is nums I plus 1 minus left bound. Otherwise, we can say int max, right? dm is m plus 1 smaller than n, nums m plus 1 minus p. Otherwise, int max. dj is j plus 1 smaller than n, right? Otherwise, nums j plus 1 minus right bound. So, and then now we can say di is smaller than dm and di is smaller than dj. Okay, it's fine. And then else if so the di is the smallest, so di is not as small, so dm smaller than di and dm smaller than dj. Then we have some stuff. Else if dj is smaller than di and dj is smaller than dm. Okay, there's no else, no more else. Okay, so this is the move, the move of the window. The window will hit left bound, or hit the left number first, right? So this is the window will hit the merging number first. This is the window will hit the right number first. Right, 3 scenarios. So if I hit the left number first, there is no addition to the window, right? Because the next right number is not included. There is no change to the frequency of the merging number, because the next merging number is not included. Therefore, no increase is possible. Right? No increase is possible. But this is not something that we need to do. All we do here is when it hits, then we just say, because this says I move forward. Actually, we shouldn't even move I forward, should we? Right? The move forward is based on, yeah, I is 0, so I is always moving forward. Right? I is always moving forward. Actually, that's not true. I is not necessarily always moving forward. So we do I, and then int I is 0 here, and then here is a while loop. Right? While this, okay. So what we do is I move forward, right, because this is first, and then we'll say dp plus equal to di and right bound plus equal to di. So here is the middle get hit first, right? So middle get hit first. Middle get hit first. Then P shall equal to nums m plus 1, right? Middle get hit first, so P updates left bound plus equal to dm and right bound plus equal to dm. This is a right hit first, so left bound plus equal to dj, p plus equal to dj, right, and then right bound is equal to nums right bound equal to nums j plus 1, but j need the plus plus as well. Here m need the plus plus as well. But here I need to plus plus, sure, and then left bound should change to nums I plus 1. Right? So we change, basically we update them, right? And then we go back up. We go back up because if this goes first, then we don't actually, okay, so we'll do the change here, right? So if the left, so we start from here and then we move. So yeah, we need to remove that. Hold on. We only move if. So the left if hits, it doesn't move. It's if left bound is equal to, right? So it's yeah, so they move forward. So it's here. So we do that, and then we say if left bound is equal to nums I, right? So we say counter nums I minus minus. So the next move in the window is guaranteed to discard nums I, right? So it's based on current. If the current is like this, then yeah, the next move will discard. But if the current is not, then the next move is not likely, right? It's not likely. We are going for the smallest, right? So the smallest of this, which means this is still included, smallest of that, and if the smallest is the left hand side, it's still gonna get included. So we do that, and then we do all of that, and if this nothing hits, this nothing hits. So if this, right? If this, yeah, so we do that, and then we say counter nums j plus plus, right? We add a new one. Okay. So yeah, we do this. And at the end, once this one is done, we'll return rest. All right. Oh boy. I got some good test cases here. So, do I have the one that I got wrong? No, I do not. How many test cases do I have? We already. Oh, I think we have one more. All right, I think the first one is not working. That's fine. I mean, it just it will take some trial and error to get this one to work. Let's see where we got wrong. 145. Did you use K? Yes, initial I used K. Oh, but this problem is you always get the maximum size. Oh, you always get the maximum size. And you try to see. Oh, that's why it's not gonna work. So you always go to maximum, right? And you say we want to change the entire thing. Actually, I don't think it's gonna work. Maybe combining this with binary search will work. But I need to first figure out why this one is completely wrong. Oh, because there is no M, right? Yeah, the M and J could be the same thing. Actually, I'm not sure. 2. Alright, so K is 1, so left bound is 1, right bound is 3, P is 2. Okay. And then P is 2, right bound, so J is 0. Yes, M is 0. Okay. And I is 0. And this is 1. Number of operations is 2. 2 plus counter P is 1, this is 3. So at this point, I think everybody is, I think the rest is so the rest is 1. Okay, if left bound is equal to num yes. So counter minus minus. Okay, so the counter, yeah, they're both 0, which is totally fine. And then we'll compute di. So di, dj, they're all the same, right? Di is 3, dm is dm is 2, and dj is 1. Huh. But j is pointing to the same thing. That's fine. Right, so in that case, skip. Alright, wait. Skip. Oh, shit. Skip. And we do the DJ. Yes. So left bound. P. Right bound. 4. J plus plus. Yes. Okay, 4 is 1. But your I is already moved forward because you have moved the window forward. Because the left bound become 2. Right? Yeah, left bound become 2. So we are talking about 2 to 4. Right? 2 to 4 with middle is 3. Okay, so what is now? I is still 0. I is still 0. That is not true though. That is not true. Because you move forward. Huh. maybe we should do is, you know, if this is larger than, right? If the left bound is larger than, then you need to do minus minus. Maybe what we should do is at the end. If left bound is larger than, if right bound is smaller or equal to nums j, set counter nums j plus plus. I don't know, I just don't do this part. But it doesn't solve the problem if I does not move forward. Maybe this is what we need. Maybe we don't do this here at all. We do this, we say left bound if it's larger than a current, then I have to move forward, counter minus. And we say if P is larger than nums M, right? Because the premise is M is equal or smaller. So if P is larger than that, then M needs a plus plus. And then here is we could just do I plus plus inside. Right, counter JL plus plus. I think that should be the end of my attempt. I think it's not going to be correct, but at least we shall be able to fix the TLE. Hopefully the TLE will be gone. No. What the hell? What the hell? Alright, it's taking too long. I'll think about it some other time.